Hi friends, this is PH1501 Unit 1 Vector Analysis by Dr. M.R. Gadhvi. Well, we will be touching up few examples in this particular lecture. Uh, in the previous lecture also we have seen few examples, and on basis of the same logic we are also considering the example number 3. Example number 3, if I will consider, then the hint figure is something like this, where they are asking about to finding out the angle between the body and the face diagonals of a cubic crystal. So this is a cubic crystals. I think you had learned the cubic crystals in some around in your 11th and 12th grade, maybe in the chemistry subject, but now we will be touching up few issues on the physics as well. So this is one corner to another corner of cubic crystal, and that is referred as a body diagonal. And if you are connecting a one corner to another corner in a one particular face, then it is said to be the face diagonals. So they are asking about the angle between them. Okay, and the second problem is the problem number 4, where they are finding out the unit vector n, and as per the figure 11, the unit vector n is coming out of a face of one of the face of a triangle, and that is a 1, 2 and 3 of their coordinates on the x, y and z axis respectively. So let us touch the problem 3, but before starting up the problem 3, let us revisit the problem number 1.2, and where they were asking about the angle between the vector a and vector b. Now vector a is in the xz plane, so naturally there would be x and z coordinates available. Vector b is available in the yz plane, so there is the y and z coordinates are available. This is something about a unit cell, so naturally there will be maximum coordinate edge will be 1, 1 and 1, and therefore my plane coordinates of the vector a and b is something like 1, 0, 1 and 0, 1, 1. So from this I can having a vector a and vector b, that is a 1 x cap plus y 0 cap plus z cap, and the vector b that is lying in the yz plane, so only y and z coordinates are available. X cap will be with the 0 vector component. So to find it out the angle between a and b, you should take the dot product, or rather the scalar multiplication of vectors, and therefore it's a dot b. And you are knowing that in case of a dot product, only the identical unit vectors components multiplication will be existing. The x and y and x and z multiplication do not exist, because the coordinate system, that is a Cartesian, that is orthogonal to each other, and cos 90 will be comes out to be vanish off, because that's a 0. So only identical vectors multiplication will be allowed, and therefore a dot b is equal to 1. Okay, a dot b is equal to ab cos theta, where a and b is the magnitude of it. So if I will find it out the magnitude, so it's under root of square of their x, y and z components, and therefore it's a 1 square plus 1 square plus 0 1 square plus 0 square plus 1 square, and therefore the magnitude of a, that would be under root of 2, and similarly the magnitude of b will be under root of 2, and that is cos theta. So ultimately it's a twice cos theta, and therefore if this is a dot b is equal to 1, so this 2 will go on the left hand side, so it become cos theta is equal to 1/2, and therefore the x is equal, theta will be equivalent of 60, माने ये एंगल 60 होगा. On the same logic we will be executing the example number 3, but maybe the same example I can ask on a day of exam with the something different logic. Let us, I can ask you, prove that these are the not the coplanar vector, or A and B are not lying in the same plane. So on the basis of vector A and their component and vector B and their component, you can argue that the vector A and vector B are not in the same coordinate, as it is here x and y cap is available, and x and z cap is available, y cap is absent, and similarly over here x cap is extant. That means this is in the yz plane, this is in the xz plane. So naturally they are non-coplanar vectors. Secondly, I can ask it out to find it out the angle between the xy, that is x and y. So one both face diagonal over here, the another face diagonal is the yz. So it is like this, that is vector b. So in xy plane I may have this vector, and in yz plane vector b is already available. So I need to find it out the angle between them, and this I need to find it out. So if you want to digest the real essence of this example, then you should stop here and you should first work out with this particular example. Anyway, the let's again come back to the example number 3 as it is asked us. So we are asked to find it out the angle between a face angle and the body diagonal and the face diagonal, and angle between them. So let us say this is the origin and these are the coordinates of your unit cell. So you having a vector A and you having a vector B, and you need to find it out the angle between them. So again we will be taking the dot product or the scalar multiplication for the vector A and B. So first of all I need to find it out the A. The vectors components could be find it out on the basis of head point minus tail point, or the field point minus source point, and therefore vector A will be given by minus x cap minus y cap. Similarly in the yz body diagonal, that is B, and that is given by again source point minus field point, and therefore vector B will be in this particular shape. So if I will go with the dot product between them, so A dot B is equal to AB magnitude in times cos theta, and that would be the A dot B will be given by 1 plus 1 plus 0, and therefore it's a 2. The magnitude of A is given by under root of 2, magnitude of B is given by under root of 3, so it's a root 2 root 3 cos theta. So 2 by root 6 under root of 2 by 3 cos theta. Cos inverse of 2 by 3 is nothing but 35.26. In some book maybe it's written, or maybe in your objective options it's given like 30 approximated 35.5, and then you should go with that. I can also limitize this way by finding out the angle at vertex B, right? I can expand this example on the other way, that let us calculate the angle between C and the B. So this is your C, so you have to assume a one angle over here, one vector over here, and the vector B, so that is this one. Okay, so you need to find it out the angle at vertex A, that means you need to find it out this is the angle between C and B. Okay, so that is here. So in the case of problem number 3, they are asking about the angle between two body diagonals. Now if you look at minutely unit cubic crystal, then you having two varieties of assuming the vectors in the cubic system, and look at here I have chosen a one angle, that is r one position vector is r1. This is origin, So this will be in the x and y plane, so it's x and y coordinates are there, and the another point I need this, so that will be on the z axis, so 0 0 1, and this is my source point and this is my head point. So head point minus source point, I can having the vector r1 by having the vector r2, and then I can take a dot product between them, and then I will be having the angle between r1 and r2. But at the same time I may having another geometry, that is the case number 2, where I may having this angle, that is in between r1. I am taking this as it is, but now the direction of angle r2 is other way than the case 1. In this case the angle between r1 and r3 is this. So consider this as a hint and try to find it out the angle between this. Let me give you the answer for this. Answer for the case 1 is 70.5. this is approximated answer. You may having a 70.36 and something like that. And similarly the answers for the case 2, and that would be the 109.5 degree. Okay, the problem number 1.4, where again I need to find it out the vector a and vector b in the face cutting coordinates as a 1 2 3 on the x, y and z respectively. We are interested to find it out the unit vector which are coming out through this particular face, and that is n. So what we will do, first of all we will find it out the vector a and vector b. Vector a is given by head point minus source point, field point minus source point, and therefore the vector a is written like this. Vector b will be written like this. Okay, and now it is interesting that you are going to take the cross product. You can take a cross product between a and b and just take the crossing of a towards b, then your thumb direction would be in the outside of this particular plane. That means that will be in the direction of the n. So the outcome of a cross b is nothing but in the direction of the unit vector n, and therefore we can solve this problem by taking the cross product in between vector a and b. So the main crux part of this problem number 1.4 is to design the vector a and b, or to find it out the vector a and b, and then you can definitely by taking a cross product you can having the outcome of this. And finally the outcome of a cross b, that is a 6x cap minus 3y cap plus 2z cap, that would be if I will go with the vector unit vector, then naturally divide by their magnitude, and therefore 6 by 7 x cap plus minus 3 by 7 y cap plus 2 by 7 z cap. So that is the way to find it out the example of a 1 by 4. Very interested in the, I can turn a little bit direction of a unit vector. Let us say the unit vector coming out through the plane. I can think about the going inside the plane. In that case you may having a cross product with the b cross a, and that would be the direction of opposite to the unit vector n, and that way also you can try it out. Secondly, I can having an idea that if this is a c vector, then if c cross a, if I will make, again the answer should be similar to the unit vector n what I have over here. So you should also try it out by yourself. Okay, are you getting me? Let me repeat. The cross product between c cross a, c cross a, c cross A, and then I can having the very much similar answer. Ideally you should get the same answer because it is the unit vector n. Okay, and the last example, example number 7, and they are asking about the finding the separation vector or the position vector. It's a bold face, so it's a vector. So r from the source point, one beginning point is 287 and the field point is the 468. Determine its magnitude r, so it's not bold face, and therefore the construct a unit vector as well. And answer is, let us say this is field minus source, so I having a 4 minus 2 x cap, 6 minus 8 y cap, 8 minus 7 z cap, and therefore 2 x cap minus 2 y cap plus z cap, and this is your position vector r. Your magnitude of position vector, that is the under root of square of their components, and therefore it's a 4 plus 4 plus 1, so it's a 9, and under root of 9, that is a 3. The unit vector r is given by this magnitude divided by this particular unit position vector, and that is 2 by 3 x cap minus 2 by 3 y cap plus 1 by 3 z cap. Thank you so much for paying attention. Stay home, stay safe, and stay healthy.